Now that I've correctly placed a single component in my spiral matrix, what I want to do is generate actually the edges of that spiral and place them correctly in the matrix. So what I mean by that is, if I look at this matrix, as I said, my general idea here is to start at 25, for example, and then generate this row and column and place them on top of my zeros matrix, and then start again at 16. And similarly generate that row and column and place that in my matrix, and then start again at 9, etc., and work my way all the way in. But before I can do that, what I need to do is generate the numbers that have to go in here. So given the number 25, I need to be able to generate 24, 23, 22, 21, etc. down to 17, and then place them on the edge of the matrix. So that's what I'm going to do now. So I've added some pseudocode to my current script to try to guide this a little bit. So from n and the starting position, we need to generate the row and column. So if I start with an odd number, since we're starting with n equals 5, to generate the necessary row, I have to finish at 25, and I have to start at 25 subtract 4. Okay, so 25 is n squared, and 21 is n squared subtract n take 1. Okay, so in this case n is equal to 5, n squared is 25, subtract 5 take 1 is 4, so 25 subtract 4 is 21, and that'll get me to the correct row position. Now for this 17, well, this column starts at 21, so it starts at n squared take n take 1, and it finishes at n squared take n take 1 take n take 1, which is equal to n squared subtract 2n plus 2. Okay, so what I want to generate is two vectors, one of which is a row vector, which starts at n squared subtract n take 1 and finishes at n squared, and the other one is a column vector, which descends. It starts at the highest value and finishes at the lower value, and it should start at n squared subtract n take 1, and it should finish at n squared take 2n plus 2. The row should start at n squared subtract n take 1, and it should finish at n squared. The column should start at n squared subtract n take 1, and it should finish at n squared subtract 2 times n plus 2. The problem with this line here is that this value is actually larger than the second value. So if I look at this, what I mean is 21 is larger than 17. The way I'm generating this now is I'm telling MATLAB to start at 21 and to finish at 17. I'm not actually sure whether MATLAB will let me do that, if it will figure out itself that the stepping has to be negative, or if that's going to cause an issue. So what I can do is just go to the command line. So the command lines are great for testing out little ideas, things you're not quite sure will work before you actually put them in script and break your code. So what I would do is I go to the command line, I'd just make a new variable called test, and I'd try to define it as starting at say 15 and finishing at 10. And what it gives me is an empty matrix. So it doesn't actually give me what I want. What I wanted was say 15, 14, 13, 12, 11, 10. And what I've gotten is nothing. So clearly MATLAB doesn't actually let me do that. So what I should do is try something like this. Again, I'm not sure that this actually works, but hey, it does. So that's awesome. So now I'm going to have to modify my code a little bit. I think the other way I could have gotten this was if I generated it forwards and then used a function called flip left right. I think. Yeah, so flip left right does exactly what the name implies and just reverses all the elements of the matrix. So that was the other way I could have gotten it. I need to add in a -1 here. Okay, so before I place these, before I do anything, I'm going to actually check that these do generate what I want. So I put a breakpoint here and didn't actually get anything, so it's because my value of n is not even, it's odd. So I'll change it to something that's even, such as 6. So my new row, well, we actually don't have anything to check this against. So I'll change this back to 5, but I'll put my code in the odd section so that we have something to check it against directly. That's the other important part of testing, is having an expectation of what the output should be. In this case, if I use 6, I don't, because I haven't actually looked at the 6-dimension spiral. So what I'll do is test with something I know about, which is the number 5. So what I need to check first is though whether this will behave the same. I think it will behave correctly. I think actually what I had would have behaved wrong in the even case, so that's actually kind of lucky. So we'll just check that. So n is 5. My new row should be 21 to 25, which it is, and my new column should be 21 going down to 17. Now what I notice here is my column isn't actually a column, it's a row. It's a 1 by 5 vector, which is a row vector. So when I try to put this in my matrix, probably won't behave the way I want it to. So I need to do something to make this a column. And the simplest way to do that, to turn a row into a column, is to just transpose it. So the apostrophe transposes a matrix or a vector. So if I check this now, I should see that column is what I want it to. It's 21 going down to 17. And it's a 5 by 1, so it's a column vector as I want it. So now I actually want to put this in the matrix, so I can do that. Now the place that I want to put the row is the first row I want to replace. So I can replace all elements in the first row by saying spiral matrix first row all columns, and that will be equal to my new row. And spiral matrix, the column has to go in the first column across all rows. So all rows, first column. Okay, so if I do that now, step through, I should see spiral matrix now has my new row and column in the correct place.